Okay. In general, there are two very general classes of ion. There are monoatomic ions, meaning they consist of a single nucleus because they come from a single atom. And the other type of class we could say are polyatomic ions. And these, of course, consist of two or more atoms that have come together to form a larger structure that is still an ion. Okay. And the polyatomics are something that you will really need to learn to name. Now, when it comes to the monoatomic ions are generally predicted in if they are a part of the main group based on group number. Remember what we talked about when it comes to completing octet. Group 1, 1 positive. Group 2, 2 positive. Group 3, 3 positive. Then we get to group 5, 3 minus. Group 6, 2 minus. Group 7, 1 minus. All right. Then, of course, there are transition elements and some main group exceptions that are what we call, that can have more than one possible ionic charge. Okay. And so we will talk now about polyatomic ions and these ions. There will be a list that you'll find amongst this module that you'll need to memorize if you go on to further chemistry, because knowing these and understanding the linguistics of them is very important. Let us talk first about monoatomic, what are called multivalent ions. Those are the ones with different charges. So a few examples of these. These are, when it comes to the main groups, there's only a few exceptions. One of them is tin, which is the symbol SN. You've got tin 2 plus or tin 4 plus. Now, the nice thing is, because they're in the same group, one of the other exceptions is lead, and lead has the same possible charges, Pb 2 plus or Pb 4 plus. Okay, that is one of those nice occurrences. The other ones outside of that tend to be our transition elements. And some of the ones that I would like you to be aware of include iron. Iron's most common are Fe2 plus or Fe3 plus. And let's see, other possibilities are you've got a copper, which can be either copper 2 plus or copper 1 plus. We've also got silver, which can be just silver 1 plus, thankfully. There are other possible charges, but the most common one for silver is just 1 plus. I'm mentioning this here, though, because I want to show you amongst its group, there's Au, not AUG. Gold, Au, is either gold 1 plus or gold 3 plus. Then you've got cadmium, which can be cadmium 2 plus or cadmium 3 plus. Other important ones, you have, I believe, nickel can be nickel 2 plus or nickel 3 plus. And I think I will just give you the list for the other side. This is just primarily examples. Now, let's talk about polyatomics. There is a whole long list of these, okay? Now, generally, the only cations amongst polyatomics are going to be what we call ammonium. Ammonium is NH3. It needs to be a subscript, not a superscript. It's actually NH4 plus. So NH3 is ammonia. NH4 plus is ammonium. So ammonium is NH4 plus. Ammonia, the neutral compound, is NH3. The other anion is what we call H3O plus, which has the name of hydronium. And we will come to that later when we talk about acids and bases and proton exchange. Okay, now, those are the only cations typically discussed. There are, in general, a whole bunch of families of anions. There are what we call the oxyanions because they contain oxygen. And thankfully, these occur in families. So you've got the nitrogen family, NO3 minus, which is going to be your nitrate. And if you're like me and you recently started an aquarium, you're aware of nitrate being the first thing that bacteria break down from your ammonia. Sorry, the second thing. The first thing they break down ammonia into is NO2 minus, your nitrite. As you can see, those are your nitrogen oxyanions. Beyond that, you can see the other ones that we've got are, let's see, the ones that are made of halogens. These are a little more complicated. ClO4 minus, ClO3 minus, ClO2 minus, and ClO1 minus. These are perchlorate, meaning above, from hyper, perchlorate. Then ClO3 is chlorate. ClO2 is chlorite. And this is hypochlorite. The nice thing is, related to this, all of the halogen ones, be it IO4 minus, IO3 minus, IO2 minus, IO minus, you've got periodate, iodate, iodite, iodite, and hypoiodite. And then, of course, you've got the ones associated with bromine. You've got BrO4 minus, perbromate, BrO3 minus, just bromate, BrO2 minus, bromite, and finally hypobromite, that'll be BrO minus. See the pattern? I hope that makes it easier to remember. A few more polyatomic anions. You've got the ones that are based on sulfur, SO4 2 minus, sulfate, SO3 2 minus, sulfite. Still with me? I hope so. You've got PO4 3 minus, phosphate, PO4, not PO4. As you can see, the pattern is the change in number of oxygens. PO3 3 minus is going to be phosphite. There are others. These are the ones in general that you're going to want to know when it comes to the oxyanions. A couple of others, carbonate, CO3. This is carbonate. Let's see. We'll keep it at that for ones that I'm going to emphasize, but I recommend you look at the list that will be accompanied with this module. We're going to stop here.